this is different. So you're
Oh,
making a pizza.
okay,
What are
okay,
some things
okay,
you need? If you're working, don't need to read that
okay,
because it's actually full of business opportunities.
okay, okay, okay.
You
Let's
have
see.
to
Yeah.
create your own drug sauce.
Oh, you're creating a pizza.
Oh, and I don't like tomatoes
Cheese,
sauce.
cheese, cheese is a
Ugh,
must. Cheese is a must. Yeah.
it's already full.
Ah,
Okay.
okay.
Uh,
Mushroom is also tasty.
pineapple. Ooh,
Pineapple.
pineapple
Who
the best.
puts? I'm
Sexy
sorry,
pineapple?
Max.
Oh, that's too much.
Who puts a pineapple in a pizza? Come on.
Who puts pineapples on nasi gorengs?
Well, I don't.
I can show
That's
you a
weird.
picture of multiple fried rice. In Indonesia, there's multiple fried rice with pineapples. So we should ruin theirs too, because that's not our recipe. That's the recipe
Pickle.
of other people from
A
other
pickle
places.
will
So
be
let's
great.
destroy theirs.
A pickle will be great, but
Pickles are good.
pineapple, in the other hand, I don't think so. Pepperoni.
It
Don't
looks
forget
like
the
corn.
pepperoni.
It
Pepperoni.
doesn't look like pineapple. That's why I don't like it.
Ugh.
Okay,
Pepperoni.
I think that's
Pepperoni.
it. Too much
Pepperoni.
mushroom. Done.
I want more pepperoni.
Wait, what? You use 6 ounces of sauce to make one pizza. How much?
Math. Ayo, come on. This is
This is
math.
too
This.
easy. It's
Yeah,
six
I
plus six.
know.
It's 12.
So how many ounces then? Okay, 12. Good. Continue. Wow, okay. So this is kind of a simulation,
Too
yeah.
easy. You use 14 ounces to make two cheese. You
Two
use 14
pizzas.
ounces of cheese to make two pizzas. Okay, 14 divided by 2 is
Come on, Bax. This is too
7.
easy,
7.
right?
7.
Okay.
I forgot 7 plus 7 is 14, so I
Yeah,
did a
okay. What
12.
about three
6 plus
pizzas
6.
then? What about three pizzas?
So it's 14 plus 7.
14 plus 7 will be? Come on, Bax. 14 plus 7.
21?
21. Good. Continue.
Yes.
Hey, by the way, can you hear my voice clearly?
But
Okay.
the way. Wait.
4.400 watt.
Okay,
Look
okay.
at
Good, good.
how the cheese is
Good.
thrown. It's just like a black line that makes cheese appear. How does that happen?
Oh, whoa, whoa, that's that could be a
Two pizza
programming
bakes at
things.
actual oven temperature.
Two pizzas big at
This
100.
is this is wrong. I
Yeah,
know the math is supposed to use that, but
yeah,
this
I
is
know.
wrong. If you do anything
It's
like
still, it's supposed to
if
be
you
still
follow
at
this
800 Fahrenheit, right? If you follow your
no no
logics.
listen wait. Because like if you do that if you 800 times 2 like there's
Yes.
someone who did this who was like doing for a bake thing for a cake and then he
Hmm.
said and for it needs 30 wait no it needs 15 minutes in 400 degrees Fahrenheit for the cake to cook and he did the math and it was 4 times the surface of the sun.
The surface.
So it can be
Wow.
1 minute.
1 minute.
So it could
Okay.
have
One.
1 minute.
Okay, let's just do it
So this
like the maker would be. Yeah, would want to us to
is
answer it. Okay.
wrong, but I'm just gonna type it in. So there's no right answer. So I'm just gonna say obvious right answer.
Okay. 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 The answer will be what, Bex, then in this questions? Oven temperature.
800 Fahrenheit.
Okay, let's see. Just submit it then. Let's see if it's wrong or right.
Wait.
Let's see. Where's your answers, Bex? Oh, okay. You're typing in other apps. Okay, it's alright. Oh. Okay. So you have to you have to explain your answers then.
Yeah.
Okay, to bake a pizza is a 800. Pizza, because heat isn't an ingredient. It is a reason it bakes. So if the to bake a pizza is 800 because heat isn't an ingredient. So if the heat is 800 and there is a pizza, it doesn't mean it would suddenly be zero. But I think what the question want us to answer is that you have two pizzas baked at 800 Fahrenheit, right? So to bake one pizza,
Ah, look, Rebecca Pro's 800 because for the pizza you always bake it at the same temperature. 800
yeah,
because
yeah, yeah. But actually, maybe for the
wait,
questions want us to answer it. One pizza is equal to 400, yeah, because since two pizza means 800 Fahrenheit, that means one pizza is equal to 400
wait.
Fahrenheit. And
Look
then
at
for
this.
four pizza is
Look at this.
1600. Oh, okay, okay.
If we double
If
the
we
number
double
of
number of
pizzas, it makes
pizzas,
sense
it
to
makes
double the
sense to
amount of
double the
sauce too.
amount of
What
sauce too.
else? What else does it make sense to double? Jesus. Not
Yeah.
this. Not this. Oh
No, no,
wait,
no, no,
bake
no.
time. How
Bake
about bake
time.
time? No, it's the exact same
Uh,
thing. But putting two pizzas in an oven is the exact same time as putting one pizza in the oven.
yeah, it's supposed to be
Total
in an
price of
ideal
pizza.
condition, it has to be like that. But let us assume
Yeah. Oh
that
wait, no. No,
delivery
delivery
fee
fee won't be doubled.
won't be double. I think it still be the same, unless you order maybe 100 pizza. Maybe it's a different case. Yeah, if you order 100 pizza. Okay,
Wait,
I even design a vegetarian pizza. The table
six
shows
plus
that.
what equals 18?
Okay. 6 plus what equal to 18? This is algebra, Bex.
Hmm.
Algebra.
So,
So,
so two for a pizza. One pizza is has 3 ounces of sauce,
what
and
was it?
six pizzas. One pizza has three ounces of
Of sauce.
sauce.
Yes,
Six
okay, good.
pizzas have 18
Yeah,
ounces of sauce. As we can
okay.
see, three pizzas uh, has 9, and 9 plus 9 is 18, also known as 3 plus 3.
Yes, good. Yeah.
So
So what
now
about
let's
the
do the thing
tomato?
by how. We
So
say that the
for two
pizza
pizza, it needs 12 slices. So what
20,
about for one pizza specs?
20 20 divided by 2. You know how
Yes,
you do
good.
it? So that means 6 is times 10. So it's 60 slices of
Good.
tomato. Who puts tomato on a pizza?
Well, some
Someone
people,
does.
someone does.
Okay.
Well, not you
30 is
definitely.
2. 2 times 3 is 6. So 30 times 3, 90.
90,
90
good.
slices of onion.
Yes, okay. So what about the pepper?
Okay, 24 times 3.
Yeah, good. Okay, so you find the quick way to calculating it. Yeah, that will be much more
That's
efficient
that's
rather
that's
than
not
calculating the
calculating though.
units.
That's
Yeah,
just
well,
finding
not.
out the formula.
Yeah. This is the formula, right? So basically, you have to multiply what you had with three. Basically, yeah. This is finding recognition. Yeah,
12. 12.
pattern recognition.
Okay,
Okay,
12. 12 plus 12 plus 12 plus 60. So that means it's 72. Let's go.
72. Good. Why don't you just 24 times 3, Bex? Why you have to start by from 12 and then add another 12, another 12? Why will you take that approach?
Oh, wait, that's 24. 24 is 12 plus 12. So it'll be 12 times 6. I know what 12 times 6 is. I actually don't know.
Okay.
Jada has 24 slices. It takes 20 tomato slices to make two of Ivan's
Ivan
meat.
Fitzas.
Ivan and
Ivan
Jada both made a mistake while making
while making
six.
6 of those pizza.
Select your favorite mistake.
Which one? Haha.
What? What?
120
Wait.
minutes.
Ivan has 120 tomato slices.
It takes 20 tomatoes sliced to make 2 of Ivan pizzas. Ivan and Jada both made mistake while making 6 of these pizza. Wow. 120 tomato slices. That's how many tomato you should have to get 120 tomato slices. It's kind of impossible. Kind of, well, not impossible, but ridiculous. 20 to okay. So okay, Bex. From the question, it takes 20 tomato slices to make 2 of Ivan pizzas. So, in order to make 6 Ivan pizzas, Ivan should take how many tomato slices then? Supposed to be taking. Give some tomatoes to me. uh, too much tomato slices.
What?
More skibidi slices.
No.
Okay.
Uh,
But what is the correct answer should be, Bex? If the
eh,
if two Ivan pizzas need 20 tomato slices, so how many tomato slices does it need to make 6 pizzas?
it takes 20 tomato slices to make two of Ivan's pizzas. How many tomato slices does it take to make 10 pizzas? 20 times 5, which is 100.
Hmm? 100. Good.
Just
Okay.
for 10 pizzas.
Okay. What happened? What happened? Are
I
you
fell
okay?
into the void.
To the void. Okay. I think you're too over dramatizing things. Void.
Describe a strategy for solving problems like the one in the previous. How many tomato slices?
Okay, describe the strategy. So, what is your strategy on dealing with the questions then?
Wait, but the question, there's two questions here. Which one do I solve? Because it doesn't help each other. Because this is from
Well, you
this.
can.
This is the
Well, you
exact.
can.
This is wait. This is a copy from the last screen, but they copied it, but it's in a different color. So
Maybe
it's a
this is
different question.
this is some sort of a follow-up question from the previous question. So the questions want you to describe your strategy after you're answering your previous problems. I think that's the questions want us to be. Okay, so describe your strategy then. How could you get 100 in the beginning in the previous questions? Okay, so you can do it mathematically or you can you
Wait.
may describe it, yeah. You may describe it also. Okay? And oh, okay. So you want to make a formula. Okay. And pizza is equal to what, Bex? T O Oh, tomato,
Omao.
tomato, tomato. Okay,
Omao.
that's that's how Britain will pronounce
What's
it.
up, my bro? We're gonna get a Omao one of this.
Tomato and a bottle of water, bottle of water, bottle of water. Could you do
Tomato.
British accent, Bex? Could you do British accents?
Yo, what's up, my mate? Bro, what are you doing with that thing?
Is
And
that
here in Britain, bruv, we use knives, not bring guns. We do a stabby stab in Britain. We don't follow our little grandchildren like little America over there.
okay, okay, okay. You're close. You're close. You're close. Okay. What about the what was it? Besides Britain, I forgot. Ireland. Ireland. I think they also have a unique accents in a way that no one could understand them. Even the Britain can't.
Oh, that Scrooge McDuck's gonna get over.
Oh, I see. Okay, 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 okay. For your level, that's very great. A uh, very amusing and what was it? Menghina. Okay, okay. So, how many tomato slices does it make to make 10 pizzas? Okay. So, maybe Bex don't write it with the bracket, yeah, and bracket pizza. Just equal. Just use equal, or maybe to a colon. Yeah, because
Uh,
maybe
Captain Susan.
Captain Caesar. Okay,
No, what is name? X something to make
something.
Y pizza. How who many something to make Z pizza? X5.
Well, I think from your friend strategy, I think your strategy are the best, yeah. Because you declare what is the variable, yeah. Don't forget, yeah. If we were to make a formula, we have to describe first what's the formula stands for, what is the letter stands for, and then you write the formula. And I think your way of writing it is the best. Okay, let's move on to the another questions.
120.
60
Too
peppers. How to
easy.
make? Okay, too easy. Okay.
Ding ding. Oh wait.
Good. Okay, good. Pizza
Yeah.
maker. Okay.
Dun. Yippee. And that's it. You
Okay.
just leave it because it saves automatically.
Oh, okay. So done that. There's nothing to work on left. There's nothing to
That's,
work on that
I mean
left.
that's something new that I learned. But to be
Okay,
honest, I
okay.
didn't really learn something new. If you can see there,
Okay. Did you have another homework or is it just that?
just that
Just
because
that? Okay.
before there was a test.
Oh,
Or
okay. What's test? What's test?
and
What is
I
the
don't have
material?
the paper yet.
Okay, it's okay. But you did you remember about the questions being asked there? Some of the questions?
Some of the questions,
Yeah, some of the questions that you remember, right? Or maybe, well,
none.
sometimes after exams you discussed it with your friends. Yeah, maybe you still
Nope.
remember a bit about it. Okay, okay. Okay, maybe for today, how about we're discussing the questions that I gave you in last week's
Huh?
in the pattern recognizing things. Last week I gave you the PDF, right?
Oh,
The
wait, wait,
PDF.
wait, wait, wait. Yeah, 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 yeah.
Yeah, right.
I remembered one of them. It's
Yeah.
I don't remember what it is about, but I only remembered that because you taught me how, I know how to put the formula thing because you
Ah,
told me.
good.
Oh wait, I do have the file here.
Ah,
Uh,
Just share screen it then. Share screen
Oh,
it.
wait, that's on another laptop. Never mind.
Ah, okay, okay.
I'm gonna
But
download
did you
it from
still?
the manager back again.
Okay, okay then. Is it about pattern recognizing also?
Yes, yes, it's
Oh,
called
okay.
line R, like
Linear. Line R.
linear
Linear. Linear.
lidar.
Linear.
Here, let me
Line
open
R.
it up.
Okay, just open
Oh,
it in the menu tab.
yippee! Okay, I'm gonna share it. I'm gonna share the screen.
Is
I'm
it
gonna
is it the
share.
exams or is it just an assignment from your teachers?
It's
Or
ah.
is it just an exercise or something?
Wait. I got it. I got it. I got it.
Okay, okay, okay.
Yippee! Oh god. Why is it so
Oh
blue?
wow. Wow.
Uh,
Formative assessment task sheets. Yeah, be
this is much better.
principal. Wow, okay. This is interesting.
This is kind
Pattern
of
one.
easy
Okay,
because
this is
it's
easy,
what's
yeah.
the name? Draw the missing values in the table given below, which is easy because it's n n plus
Yeah.
e equals
And plus
m.
and plus
n n I mean stage number
yes.
plus e equals
E.
number of matchsticks.
Oh, N plus E, which is number E stands for the number of the matchsticks. Okay. Okay, draw the
I already
diagram
did
for
this.
stage 4. Okay, what is the have you draw it?
This
Have you drew it? The
yes, I
diagram
already
for
did it.
stage 4.
It's like
Okay.
it's
This one,
it's
right?
so easy.
In the right,
Yeah.
in the right.
This one is 10, 13, 16. Then
Okay,
in
good.
here, it adds 3 every turn. Let's go
Every
next one.
stage, yeah? Every stage. Okay.
Every stage. Write down a
Okay.
general rule from M for M in terms of N. I already told you
Okay.
that before. I don't know how to do this or this.
Okay, let's do that. Okay. Let's do that.
So
Okay, can
let's do
you
it. Because it got
uh
deleted in mine.
okay, good. Okay, can you go to the previous questions, the key 1 until key 3, the original questions?
Key 1.
Yeah.
Which one?
The matchsticks pictures. The one that have the matchsticks pictures.
Oh, this? Oh, this.
Oh, I don't see anything in my screens.
Are you sure
Only the
about that?
word, the Microsoft Word, but it doesn't have anything on it.
Wait a minute. Wait. Be careful. Files from internet can contain viruses unless. Wait a minute. I can see everything in here.
Well, it's the
Oh, wait.
default on Microsoft Word. So yeah, it's to prevent you to open things that you do not want it. Okay. Still haven't seen anything.
Much better.
Okay.
Ah, I fix it.
Oh, good. Okay, good. Can you go to scroll up? Ah, okay.
Oh, the Q1 isn't like it's just this. I don't understand it. It's just draw the diagram for stage 4.
I want to
And
screenshot
it's already
the
and it's
stage 1
already
and
filled.
yeah. Oh, yeah. It's already filled. Okay. Can you scroll up
What's the
again,
point?
Bex? Scroll to the upper side of the
Oh,
questions.
scroll up
Yes. Okay. So
here.
okay. Yeah. Okay. Okay. Good. To the bottom now. To the bottom. Okay. Okay. Wait. Let me share my screen. Yeah.
But I already finished this. I don't want to learn again, please. Ah.
I'm just need the original question. Yeah. Because I need to see the pattern. Okay. Let's just discuss the key 9 and so on. Eh.
EP.
Okay. Good. Okay, this is okay. Can I see the questions that you have confused on the questions? Which one
None
that
of
you
the
confused?
questions I've confused that.
Oh, well, how about the key 11 that you said that you don't know how to do it?
Q11?
Key
Q11?
11? I forgot. I forgot. So, can you scroll down?
No, scroll up.
Oh,
Here.
oh yeah, key. I'm sorry, key 6. Key
For
6. This one.
n under 3, then n equals 1, then m. Test your general rule.
This is still
Wait,
about the matchsticks thing, right?
yeah. Okay, from using my general rule for m, n equals 1, then m equals 4.
Good.
N equals 2, then m equals oh wait, I was wrong. Sorry. It was it was supposed to be m equals here. Let me write it down. It's supposed to be m equals n wait
Yeah.
n n times 3 equal
Okay, good.
uh
And
plus
equal
plus
to
n.
n times
You
3
understand
plus
it?
n.
Like for example, in here, stage number one,
Yes.
one, one. Oh wait.
I think, okay. I
One
think
times three is 3 plus
3.
n. So 3 plus 1 is 4. Then there's
Oh,
2.
okay.
So there's 2 times 3, 6 plus n. 6 plus n.
N is
It,
equal to 2.
oh,
I think there's a loop on on your general rule. Okay, how about the general rule again? Okay.
how about the one
Remember,
before?
remember we have to start from the base case. Which one is the base case in this context specs? For
Uh,
the base case is stage number 1, right? In this stage number 1. Okay.
yes.
So in the stage number 1 we have 4 matchsticks. And then
Yes.
yeah, after then, yeah, the number of matchsticks will always add up to 3, yeah. So 4 and then plus 3 and then plus 3 again, plus 3 again, plus 3 again, according to the stage number. Okay, so we have, you see that if we have stage number 2, that means we add 3, right? If we add
Yes.
stage number 3, we add with 6 from the original number of matchsticks in the first pattern. Okay, so okay, let me share my screen. Yeah,
Yes.
I'm gonna share
Oh
my
wait.
screen.
Oh, I found out that which one. Oh, sorry,
Okay,
I was
okay,
wrong with that one.
yeah, okay. Always
Let's
remember to start from the base case. Yeah, which is stage number 1 in this case. Okay, so what is the
let's
formula then?
here. It was n
N.
times n.
Yeah.
Wait.
Okay.
N times n
Yeah.
plus 3
Plus 3
equals
equal to m.
m. Do you know why?
Okay. Why?
Let's say 1 times 1 is 1 plus 3
Yes.
is 4. 2 times
Yes.
2 is 4. 4 plus 3 is 7. 3
Okay.
times 3 is 9.
Plus 3
9?
is 12. Nah, so the key,
Well,
yeah, so it
3
only
times
work on
3
the is 9.
is 9.
9. And then
9
you add
plus.
C. At 3 it will be 12. So there's, I think still there's still a loop in your uh general formula. So what is the exact thing? The exact formula then? Remember, start from the very base, and then you add from the base case what you do with that base case. Yeah. Okay. Do you want me to discuss it, or you still want to think about it?
I want you to discuss it because I've never been taught about that.
Okay. Okay. Let's see. Yeah. Okay. Let me share my screen. So Can you see my screen, Bex?
Wait. Yeah.
Okay. See, yeah? Okay, let's see. So we have stage number one is equal to 4. Yeah, this is 4 matchsticks. Okay. Remember, yeah. So we have 4 matchsticks. We have 4. And then stage 2, we have 7. And then stage 3, we have 10. Okay. So 4, it will be 13. And 5 will be 16, right? Okay. So you see that the base case or the start of this sequence start from the state number one, which is equal to the number of matchsticks. Okay, we have the base, yeah, the initial number that we had, we have 4 in the beginning. And then after we have 4 in the beginning, we always add it up to 3, right? And for the second stage, we add 3. The third stage, we add 3. The fourth stage, we add 3, and so on. Okay, so you see that uh, the pattern is depend on two things. It depends on the initial conditions, in the beginning conditions, and then it always add up with 3 as the stage number goes on. Okay, so you see that if we have stage number 1, we doesn't add anything, right? We
Yes.
doesn't add it with 3. With stage number 2, we add it with 3. This is plus 3. At the stage number 3, we add plus 6. Now, we know that 6 comes from what, Bex? It can be 3 times 2, right?
3 times 2.
Yeah, 3 times 2 is 6, right? Yeah, 3 times 2 is 6. Okay, so what about 4? The 4 we add with 9. Yeah, so this is 3 times 3. At the fifth stage, we have plus 12, which is 3 times 4. You see that the 3 always constant, right? Never changing. Never change. Okay. What changed is that how many we times 3 with something. Yeah. So at the stage number 3, we add with 2. At the stage number 4, we times 3 with 3. And then at stage number 5, it always uh uh multiplied. We multiply 3 with 4. Yeah. Which is, if we want to see it in much more general form, we see that n if we have n stage, that means we added up the initial number, which is 4, with 3 times n minus 1. Did you see the pattern, Bex?
Where did you get the 1 from? I mean, I from.
Oh, I is the initial number, which is 4, right? We know the initial number is 4.
Oh,
Yeah, I forget to add the descriptions of it. Okay, so if we want to write down the general formula, so the general formula for the number of matchsticks will be equal to m equal to 4. Maybe let's start from not using the number immediately. So we start from saying the formula first in general. So I initial number equal to 3 times n minus 1. Okay.
plus
For
or
every
equal to? You said
what was it?
You said I equals
Oh,
3
I'm
and
sorry. I plus. I'm sorry.
oh, plus plus plus. Okay.
I plus 3 times n minus 1. Yeah. So it's kind of my mistakes during writing
Yeah.
something. Yeah, what I say don't align with what I'm writing. Okay, so don't forget, yeah, always when you're making a formula, always states what the uh, variable, what the letter stands for. Okay, so if you have m is equal to what? M is equal to number of matchsticks. Number of matchsticks. So I is the uh, initial number of matchsticks. Number of matchsticks. What about the n? What is n stands for, Bex?
N.
Yeah, n. So we created this formula, right? So what does n stands for then?
Stages.
Yes, good. Stages. Okay, so if you want to write the final formula, then the m equal to I equal to what, Bex? Initial number of matchsticks. In the beginning, we have what,
4.
Bex? 4. Good. And then, well, 3 times n minus 1. Yeah, of course. N minus 1, well, you can simplify it. Yeah. So you can multiply 3 with n, 3 with minus 1. But I think that will be unnecessary. Yeah. I think just write it as it is. Yeah. So n minus 1. Yeah. Well, and the n itself can be changed according to our desire. Yeah. So for example, uh this is what was it? Useful to answer Q5. So how to test your general for M then, Bex? If you have the formula.
Hmm.
So the question wants you to test your general. Okay, so we have the general rule is Mn is equal to 4 plus 3 n minus 1. So when n equal to 1, then m equal to,
When n equals to 1,
yes,
that means it's 4.
4. Good. Because 3
And 1
times,
minus 1 is 0.
yes, good. Everything multiply with 0 is always 0. So this is equal to 4. So what about n equal to 2 then, Bex?
5.
Hmm, n equal to 2. So the
Oh,
m,
n equals 2.
yeah, equals to 2. Then the m will be,
Well, first the n needs to be minus 1. So that means it's 1. 3 times 1 is 3. And 4 plus 3 is 7.
7. Good. And okay, maybe we have we because the question asks for n, so n less than equal to 3, less than or equal to 3. So how many n that we should test, Bex? So we have to test
n
for n equal to 1. Yeah, for this question. Yeah, for this question kan the question asks for n equal, for n less than or equal to 3. Yeah, so you have to test your formula. Does the formula give you the correct number of matchstick or not? Okay, so
Hmm.
therefore from this statement we have to check for n equal to what, Bex? N equal to 1, n equal to 2. Does we also have to check for n equal to 3, Bex, in this case?
For n equals to 3. Ooh,
Yeah,
n equals 3. That's not equal, but let's say it's 3. If it's n equals 3, then
yeah,
that means n minus 1. 3 minus 1 is 2. 3
yes.
times 2, 6. 6 plus 4. What's 6 plus 4?
Ayo, Bex, 6 plus 4. This is an easy question. Yeah, 6 plus 4, Bex.
Oh, 10.
10, good. But my question is that, do we have to calculating it? Do we have to calculate it from these
No.
questions? No, because? No, because?
What?
Okay, you already test for n equal to 1 and n equal to 2, right?
Yes.
Yeah, now, do we have to also check for n equal to 3 in this case, Bex? In these questions?
N equals to
3. N equal to 3. Do we also
yeah.
have to check it out? Why?
I check it up.
Yeah.
Well, we need to check n for 3.
Yeah. Do we have to check for n equal to 3 in these questions?
I don't think so.
Why? Why? Why do you think so?
I don't think so.
Yeah, you don't think so. Why would be your answer be like that? Why would you think that we don't have to check for n equal to 3?
Oh, oh, that's what you said.
Yeah.
I'm
So
hearing you.
if we
But
have
we
to,
need to, because if we don't know what n equals to, then we were not gonna know what m equals to. Unless m equals to something, then we're gonna know something.
okay,
But
okay.
unless both of them don't, then we don't know.
Oh, okay. So the final conclusion. So we or should we not check for n equal to 3?
We shall.
Oh. Okay, okay. So, here's the thing, Bex. So here's the thing.
What
So,
if
the
everything is
question,
blue?
the, the question say that we have to test our general rule for m, right? Now, the question asks for n less than or equal to 3. So, uh, for n that is or less than or equal to 3, we have to check it. That's what the question asks. That's what the question mean. So you see that n equal to 1 is correct, right? For this statement. Yeah. So just replace it with is 1 less than or equal to 3? Well, 1 is less than 3, so it fulfill the statement. What about the n equal to true? When what about to n equal to 2? Oh yeah. It also happens to be the same result with n equal to 1. It also fulfilling the statement. It also true for the statement because 2
Okay.
is less than 3, right? So what about n equal to 3 then? Do we also have to check it based on this pattern? Is
Yes.
3 is less than or equal to 3?
Equal, because it's the
Yeah.
both is 3. How is there two
Yeah.
threes?
Yeah. So it is equal to, yeah. So it fulfill the statement that the question asks. So that's why we also have to check n equal to 3 regardless of the question, uh, uh, regardless of did the question write for when n equal to 3 then n blah blah blah. It doesn't matter, yeah. We can write it in the other boxes, yeah. We can write it on the other side, yeah. Because the question asks for n less than or equal to 3. So that's why we also have to check for n equal to 3, yeah. So that's what I meant earlier, yeah. That's why I meant. Yeah. So we have to. So if I gave you for test your general rule for m with n less than 5, for example, how many n that we should check, Bex? We start from n equal to 1, right? And then
Okay. N equal to 1, n equals to 2, n equals
good.
to 3, n equals to 4. And then no
Yeah.
more, because if we say 5, it's not under 5. It's more, no, not more than 5.
It is equal, right?
It is equal, but not
Yeah.
more than 5. Is it more than 5?
5 is equal to 5, of course lah. So this did you did you have learned about this symbol specs?
Yes.
So if we have the symbols, that means the statement we
5
call
is
this
bigger
as
than n.
yes. So this if we
So
have this
if
statement,
the n is 5, it can't be
yeah.
bigger than 5 because it's the same thing.
Well, it is equal, so it doesn't less and it also doesn't more than the number 5. So it is
Well, it's
equal.
not, so it is equal, but it
It
isn't
is
under
equal.
5.
What was it?
It's not under 5 though, so that's why we don't count it as smaller than 5.
Nah, that's the trick. That's the trick, Bex. So if we have this sign, less than or equal to, that means, the condition
Oh,
is true. The condition is true if the number is less than the number we compare, less than the number we compare, or equal to the number we compare.
but that's not the equal sign. It's the bigger than sign.
Yeah, it's supposed to be like this, right?
Yeah.
Yeah, but
Oh,
this
you
is the
put the line under it.
yeah, this is the line under it. So it represents an equal. So if
Oh,
I write it like this is only less than. If I wrote it like this will be less than or or equal to. Yeah. So in this condition, we also have to check for n equal to 5 because 5 is equal to 5, right? Which is
wait.
true for this statement.
That doesn't mean equal, because if you look at that for n equals or less than 3, the lines, the top and bottom line for the equal that's merged in isn't equal to each other. One is like this, and one is, it's not the same. I forgot what the name is, but
In this
the
case,
angle.
3 is also fulfilling the statement, fulfilling the conditions.
Oh, no, no,
Because
no, no.
like
The
this, Bex.
sign. The sign qualifies as equal, even though it's not, because the equal means that the lines are exactly in the same length and the same orientation, but one of them is like this and the other one is like this.
Oh, like this. Like this.
I mean, that's what you are drawing, but the way the computer is,
Like
it's a
this.
straight line at the bottom. No, put a
Like
line
this.
under it. Yeah, like that.
Oh, this is just the same. This is just the same. Just the same. Apa? Just the same symbols. Yeah. So,
But it's
humans. Yeah, just the same. The same. The same. This is how computers write it. Computers. This is how human usually write it. I'm sorry. Okay. Let me take a call for a moment. Yeah. Wait a minute, ya, Bex. Ya.
yeah. Okay.
Halo, Ma. Lagi ngajar dulu. Sebentar ya. Oke, yuk. Okay, continue ya. Okay, so this is just showing us the same thing. Okay, this is exactly the same thing. Okay, yeah. So,
Okay.
okay, this is exactly the same thing. That's why n equal to 5 is also included in this condition. Okay, and also that's the same reason why n equal to 3 is also included in this question. Okay, so we have to write n equal to 3 ya, Bex ya. So we also have
Okay.
to check n equal to 3. So for n equal to 3, m equal to how many, Bex? Based on our formula?
N equals 3, that means M equals 10.
N is equal to 10. Okay, what is the concluding statement? So what can you infer from this test that you have done earlier?
Statement.
Yeah, concluding statement or the summary of what you have done.
But it's a concluding statement.
Yeah,
Uh,
well,
it is technically
concluding.
summary, but if you take it literally, it's concluding statement. It's just a normal statement that you use to conclude something.
Yeah, well,
So I can
okay,
say
so
anything to conclude this.
how would you conclude the all of them, all of these process things of the
But to
process that you.
summarize it, I would say that my formula works.
Yeah, okay. Wow, that will be sufficient, yeah, for your levels. Okay. Therefore, our formula
I'm
Our
gonna go
formula
beat this.
works for every n, yeah, for every stages n or stages. We could say it like this, yeah. This is what we call. Remember what this kind of thing. The method. What is the method called in mathematics? Bex,
The
if you still remember,
mathematical.
yeah, the mathematic rule, the mathematic method in doing like this, in doing things like this will be called what in mathematics specs? I've told you earlier, yeah, in the last week.
Hmm. The rule of
It start
mathematics.
from it start from I. The rule of the way we call this. There's the name for it. The method. What was
I.
it called? It starts with I.
Initial.
No. No, 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 not that. You still remember, Max? What was it
I kind
called?
of forgot about that one.
Oh, okay. Induction. Does
Wait.
it ring a bell? Does it ring a bell? Inductions.
Destruction? Oh,
Induction.
destruction.
Inductions.
I know. I remember. Why I remember it is because you said it like it's
Yeah.
destruction instead of induction.
Induction. Yeah, yeah, yeah. Induction, yeah, Bex, yeah. This is the method of induction. So we only analyze some cases to make a general conclusion, right? Like
But what
this.
happens if you do what I did before when I did the mistake when it turns out it can only do with n equals 1 and n equals 2
Well,
and
well,
it
that's
turns out
also.
but what happens if it turns out after like the billionth of or thousand it suddenly doesn't work?
That's the thing. That's it's an interesting things. You said it, yeah. The way that's an interesting questions actually, yeah, uh because there is because of this because of that, that's why improving formula, yeah, we cannot just use a sample case to make a general solutions, use in a higher form, yeah. Maybe for this cases we can do inductions, yeah, because we can uh believe ourselves that okay, this will work for a for no matter how big the n will be, but in a much higher mathematics there will be a more robust, yeah, robust approach to prove a formula. For example, the formula of pi r squared, which is the area of circles, it doesn't just came out nowhere, yeah. So it doesn't just come from skies and then well we just accept it as it is, you know, no, there's so there's a long way before we could make that conclusions, yeah. I think you'll learn about it later, yeah, but for this formula I think it will work, yeah, I hope so, yeah, I hope so, I think it will work for a higher form. One of the interesting case is the case of dissecting a circle. Okay, one of the cases that uh
To cut a circle in half,
yeah, so like
it's a
this. Okay,
semicircle.
this is a circle, right?
Yeah, you're
So
gonna
if
do a
I cut it,
semicircle.
yeah, okay,
That's a semicircle because it's almost a circle. That's why it's called
yeah,
semicircle. Like how
let's just assume,
semi-automatic is not automatic, but it's
let's just
almost.
assume it is a perfect circle. Okay, okay,
Oh
okay,
no no
so
no no no! Semicircle is the semicircle is the semicircle. It's almost a circle because it's half a circle.
yeah, 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 a semicircle will be look like this. This is semicircles because this is a half of a circle, right? Of a circle
That looks like
of.
a cave.
Yeah,
You
well, my drawing
you
skill
drew a
are
cave instead of a
yeah.
semicircle.
Okay, okay. Okay, let's go back to the ini ya, to the
Eh,
circle ya. So if I
so
cut
circle.
this circle into with line like this, how many the sections will be?
2,
2. What about like this?
4,
4.
8,
Okay.
9.
8 and so on, right? And so on, right?
Yes.
No, no. Different case thing. Okay, wait. Let me revise my approach. Okay, so if I have this is a circle, so if I draw a line like this, so I drew 2 point, right? This is
Yes.
1 and 2. So if we have one circle, we have 2 point, right?
Yes.
Okay, so if I have this, it will have 1, 2, 3.
4.
1, 2, 3, 4, 5, right?
Oh, the connection of the
Yeah,
lines.
the connection of the lines will also be counted. So if I have like this, circle like this, maybe I'll do it like this. Yeah, set. Yeah, I'll have one, two, another 1, 2, 3, 4. Yeah. So if you see the pattern, yeah, it will, well, it will have a pattern. Yeah, I forgot the exact pattern. Yeah, but uh the pattern, if you create the pattern with these sample cases, well, it will seems work. It will seems work. Yeah. But
It will seem like it will work.
yeah, but turns out after some iterations, after some trying and error, they found that at, if I'm not mistaken, in the 11th iteration, it doesn't work
Yeah.
suddenly. Yeah, so that's the cases where, well, induction is not really a method that we should rely on only. Yeah, so there should be in
Mm.
proving things in a much more general form, we have to use a more rigorous, I would say, a rigorous approach. Yeah, so that we cannot, we don't have such cases exist in our formula. Yeah, so that's the thing. Okay. But okay, for these cases, we assume that it works. Okay, even though mathematically, if we want to uh, show show it that it is true for every n, that will be a hell of a work. Hell of a work. Okay, so did you have another question, Specs, in the key six for the key six? What about the key six? If I'm not mistaken, the key six will not be very different from the key five.
Yeah, that's just doing the same thing but with different
Yeah.
numbers.
Okay. For the final question, let's discuss the question from the PDF that I have been given to you. Yeah. Okay. What about that? How about that? You want an interesting question, right? So here you go. Here you are.
We
Oh my God, you're in space now. Okay,
I'm full.
Bex.
Yes.
Okay, which one? Yeah, I think which one? Let me see the questions first. Yeah. Okay. Okay, I think this is gonna be interesting. Okay. 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 Good. Okay. Can you see the question, Bex?
Yes.
Okay. Read it then.
Setelah acara pentas musik, banyak sampah di
Boleh
lapangan.
dulu. Ya.
Robot
Ya,
pembersih
ya.
mengambil sampah yang ditinggalkan penonton seperti
Gambar.
gambar
Gambar
beri.
berikut.
Robot pembersih akan bergerak mengambil sampah yang paling dekat. Kemudian ia bergerak dan sampah paling dekat berikutnya. Robot mengulang langkah sampai semua benda apa yang dipungut paling akhir oleh robot.
Okay.
Wait for a second.
Okay,
Uh,
good.
he will first go for the blue cup right in front of him,
So it will
then
be
to
like
the
this, right? It will be like this, and then
it will go to the other blue cup at the bottom, I think.
from the pictures, which one is the nearest? This one or this one?
Oh, okay then.
Ah,
It will go to the circle cylinder thing that I will think about as a cup.
like this, yeah.
Yes. And then
Okay,
to
and
the
then
bottle of beer,
good.
the the mushy wooden porridge that is turned into this cardboard thing called paper,
Yeah, okay, okay. You don't have to describe it very precisely. Okay, like this, yeah.
and another cylindrical thing that I don't know the name of, probably a can
Okay,
of
like this.
beans.
A can. Let's just call it a can. I think that's a can.
And then later it will reach the other bottle.
Okay, like this. And then
Then paper,
paper, good.
then cup of water.
Cup of water, good. So what is the last?
Cup of water.
Then okay, good. And the answer will be, let me check it. The, the answer will be the blue cap, the blue bottle. Yay, yay,
Yeah.
yippee. And the track, the path that you chose is exactly the same as in the kunci jawaban. Wow, great, great. Okay, another question. Yeah, I think this is too easy. Yeah. How about we do the high schooler
Yeah.
versions of this type of questions?
Yes.
Okay, okay,
High
good.
school, high school, high
Yeah,
school.
okay.
High school.
Let's see ya. Bebras.
High
Only
school.
one question ya. Bebras SMA. Okay. Let's see. Bebras SMA. I think this is gonna be interesting. Okay. Bebras SMA. What were you doing, Max? Okay. Wait a minute, yeah. Let me load up the PDF first, okay? I think this will be an interesting question for you, yeah, because you asked for a difficult question, then we're gonna discuss it then. For high school student, yeah, I think high school student version is much more challenging than the elementary school.
Jalan Gening.
Challenging,
Jalan Gening.
challenging. Okay, okay, good. I have opened the PDF. Let me
Challenging.
challenging,
Challenging. Ging.
challenging.
Challenging.
Okay, this is okay, okay. So okay, this is interesting. Yeah, okay. So can you see the questions, Bex? Yippee.
Barang-barang
Okay.
barang
Berang,
berang
berang. This not
berang-berang
barang. Berang.
berang-berang menemukan satu alat untuk mendeteksi wajah tersebut kamera. Alat tersebut
Mhm.
bekerja dengan dua langkah. Transformasi foto wajah menjadi semacam smiley yang beri dua titik dan garis yang menunjukkan posisi mata dan mulut.
Good.
Deteksi apa wajah tersenyum dengan mencocokkan gambar hasil tahap 1 dengan pola yang terdiri dari garis dan titik hijau. Wajah
Mhm.
dideteksi sebagai wajah tersenyum jika dan hanya jika gambarnya semua titik hijau dan tidak menyentuh garis merah. Wait, what? So
Can you
if one of them don't even have if one of them don't have an eye, how do they not have an eye?
That's why this
So
is for
someone
high
who
school.
got like, for example, if there's a veteran that doesn't have an eye and is called a cyclops, cannot smile.
Well, this is how computational thinking works, right? So we have to do what we call as a generalizations, yeah. Generalizations, yeah. Generally, people will smile, people will be detected as smile based on this question, yeah. People will be detected as smile if, yeah, first, yeah, if, yeah, this is the key point, yeah. So based on this system, yeah, we assume based on the system that person is detected as smile if the the projection, this is the projection, right? This is the projection. If the projection touch all the green sections and do not touch the red line.
Yes.
Okay, so
And
we have 10 projections here, 1, 2, and so on. You have to check whether each projection is detected as a smiley face or not. So that's the question.
so number one is a smiley face. Second is
Smiley, good.
no. Third
No.
is
Oh, okay.
technically
Let's
no
start from the second. Why did you call it not a smiley face? Why would
because
did it?
it's half a mouth, and
Ah,
one of
so
them needs to connect to the other green dot. And the
oh
third one needs to connect with the green dot again. And the
yeah.
lines go from this to this. And to be honest,
Oh.
from what I see, the smiling face, if it's transferred to a human face, looks like. So when someone does this, it's technically. So technically, this is wrong. I mean, technically is right, but literally no.
Based on the system, yeah. Again, Bex, we
Based on the
determine a
system, but
person,
if
yeah,
it's
based on the
based
system.
technically, it's from the technicals.
Yeah. Okay. So okay, let's start from the beginning, yeah. For the first one is smiley, yeah.
Beginning, beginning.
The second one, smiley or not?
No,
No. The third one?
no,
No. The fourth?
no.
No. The fifth? This
Almost,
is
but no.
no, yeah. No.
No, but almost.
Almost. How could you say almost? Why did you say
Because
almost?
the lines doesn't cross the red line except for the end, which doesn't go connect. That doesn't connect to the green dot, but doesn't cross the red line.
Okay. Does it does it uh does it touch the green section, the green point?
No, 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 no. It didn't. It did. It only. It gets 3 out of 4 of the greens, and it doesn't touch any of the reds.
So it's a smiley then.
It doesn't. It didn't touch the. It didn't touch all of the greens.
Okay, I see where you're okay, okay. Why can you say that the which in the bottom, why did you say that it doesn't touch the other greens? It
Because
does
it
it
went
touch this one?
down.
Does it
Because
touch
it
this
went
one?
down instead of up.
Oh, okay. Let's see later, yeah. Okay. Let's see later, yeah. So what about the this one? No, yeah. How about this one?
The sixth one is literally who has eyes in their nose.
So,
Not in this nose though, but here. How? I mean, someone probably has that, but
yeah, yeah, yeah.
no joke. He's trying his best to smile, but he isn't.
Okay. So how about the six? Is it a
Yeah,
smiley
no,
or not? No.
it's
Okay. What
not.
about the seven?
It's not a smiley. Wait, it
Based on the
is.
system backs. Based on the
Oh, wait,
system
never
backs.
mind,
Again.
never mind, never mind. I thought it was because it's connecting the green dots, but it isn't because it's under the green dot. So it's actually touching red and not touching the two green dots.
Okay, let's just keep your answer first, yeah? It doesn't. So what
X,
about this one?
X, the
X. What
mouth
about
is
this
too
one?
high.
What about
Oh my
this?
god, he lost an eye.
Yeah, okay. What about this one?
Touch the red.
I touched it the red. Okay. So it's not a smile then.
Yes.
Okay, let's see the answer, yeah? Let's see the answer. Okay, this is kind
Let's
of difficult,
see.
so it's not a big thing if you do it wrong, yeah? Okay, it's not a big deal. Okay, let's see the answers. So the answers will be four. It should be four smiley bags.
Where's the four smileys?
Let's see, yeah? So the first one, you're right. You are right. Now the second one it is a smiley because it touches the green and it doesn't touch the red line.
Oh wait. Oh yeah.
Yeah,
Oh
right?
wait. And though it's hard. Okay, you can't just copy and paste those red lines and green dots onto
That's
something.
why we have to have that some sort of intuition on where is the red line, where is the green line, yeah. So if you see it, yeah, the red line will be on these sections, right?
Oh. Oh, you can't be under the red line. I thought
Yes.
the red lines were a bit up a little bit, and and there
No.
is space under the mouth thing, but
Ah,
there
okay.
isn't. Because of that, before I thought it was under the mouth is under the red mouth line.
Okay, okay. So yeah, it's all right. It's all right. It's all right. And then we also have this one is a smile. This one is also a smile. This
All
one?
of the ones, almost all of the ones that I said is almost a
Yeah,
smile,
but yeah, but
is a
I
smile.
you almost did it correct. That's why I'm kinda aduh gemes banget ini hampir benar ini. Aduh. But it's all right. It's all right.
I want to fly
Okay.
out to space.
It's all right. So, and also the last one is also correct. The last one is also correct. So, what is your opinion, Max? Is it compelling or
The
interesting question?
technology, the technology here is an absolute failure.
But
None of
how
these are, almost all of them that are smiling isn't smiling. Smug is technically flat smiling if you can see some of them and if you know what smug is. And to be honest, just because someone lost an eye or has their eyes, I don't know, in the middle of hell, doesn't mean that
well
they're not smiling.
well that's why Max in computational thinking there's something that we call generalization and abstractions. So generalizations is basically uh,
Ooh.
when you see the program, yeah, the program here starts from the problem that we want to detect smiley gesture from someone, right? But of course, the smiley gesture is somewhat relative, right? Somewhat relative to others, yeah. Some might say that the first picture is a smile. Some might say the picture is a smile, or the third picture is a smile. It can be relative. That's why in computational thinking, we are trying to generalize it in a much more objective quantity, in which we try to generalize it. We try to quantize it by, oh, okay, let's assume rather than seeing it in a relative way, let's just let's just assume that a person is smile if in this case touches the green section and doesn't touch the red lines, okay? Because again, the problem is too complicated if you really want to solve it very directly. Of course, it will be difficult, yeah. But it will be much more easy if we do it this way, yeah. But of course, yeah, later on there will be improvement, right? Improvement. Maybe there will be a database for checking the smile for people who has suffer a disease, for example, lose their eyes, one of their eyes, or maybe anything else. Yeah. But yeah, in the
Oh,
beginning, we
that
started
reminded
from
me of
this.
something actually.
Oh, what was it?
So there was a man who was
Yes.
that in who was caught doing this on the camera, and he
Yes.
was driving. So they fined him for like 300,000 or something, and he didn't want to
Mm.
pay that because that's in dollars, by the way.
Oh, dollars. Okay.
$300,000 is
Mm.
$300,000 times 14 is in rupiah. You know how much that is?
Uh-huh. Yeah. How many?
What is 3 times 14?
What was it?
What is 3 times 14? First, we do 4, 4,
Yes.
4, which is 12. And then 10 times 30 is 30. So that means it's 42.
42. Wow.
But you must remember the other zeros at the back. It's 300,000, not 3. So there's a zero, 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 zero. There's 5 zeros. So that means 5 zeros. And there is a 42. So that means it's 4,200,000. So 4,200,000 juta. Just
Million.
just because he did this. So the thing is, he was the one who was computing the camera system, and
Mm-hmm.
he didn't even have his phone when he was driving. But none of the courts believe him until he was doing some stuff, checking the database, and then he
Mm-hmm.
tested it out by doing this, and then it worked.
Oh.
It thinks that he has a phone. So he sent it out, and
Oh.
only after 1 year, finally he was saved.
Yeah, yeah. Well, that's a uh that's how technology improve, right? So we start from that's why for example in a game there's a beta testing, there's alpha testing, yeah, before they launched it to the public.
But even when they launch the game, multiple people find out like multiple glitches that they
Yeah,
keep
yes.
that sometimes, only sometimes, if the glitches are actually fun, they will keep as
Yeah, they will keep it.
a thing that happens in the game normally,
Yeah, yeah,
and
yeah, yeah.
the other one is a glitch that is also fun or unplayable, and they deleted it. Well, if it's unplayable, then of course it's gonna be okay. But multiple glitches that are actually fun and isn't doing bad, actually doesn't, it follows the rules. It doesn't like make you overpowered,
Yes, yes.
but they delete it. So
Yeah, 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 yeah. Well, that's why a developer usually do beta testing or an alpha testing before they launch it to the public. It's to find out whether there is a glitch, whether it's benefit the benefit the user or not. Yeah, well, that's the point
oh,
of beta testing.
no, I mean, I'm talking about glitches that we found out in games that is already done after years.
Oh yeah, well, of course we are still a human. Yeah, developer also a human, so yeah, they always do mistakes even after beta testing over. Yeah. Okay, Bex, maybe before we end our discussion for today, is there anything that you wanted to ask?
No.
Oh yeah, okay. I'm gonna send the SMA versions, the high school versions of the Bebras. I think it will be much more interesting to you, yeah? I'm gonna send that and I'm gonna see you again in Thursday. Yeah? Bex, yeah? Okay, Bex. Bye bye, Bex.
Makati.
Okay.
Bye bye.
Makasih. Bye bye. I'm gonna send the
I've
PDF
been
to SMA.
holding my piss. Bye
Okay, okay, just take
bye.
your piece then. Okay, go, go, go.